This program covers the Cameron Model D annular blowout preventer, which has been made in sizes from 7 1/16 inch 3,000 pound through the 13 5/8 inch 10,000 pound working pressures. Later models and higher working pressures are covered by additional programs. The Cameron D annular blowout preventer is the result of years of research and development. This design provides a tough packing element that features superior life and ease of replacement. Most DBOP sizes and working pressures are shorter in height, with less weight than other annular preventers available. It also requires less fluid to operate, allowing rapid response to closing and opening functions. The D preventer is simple to use, easy to maintain, and has an operating system that can be completely rebuilt or replaced in the field. The Cameron D annular preventer complies with API and NACE specifications and is suitable for H2S service. The operating system is protected by a dual lip seal and vent configuration, which eliminates the possibility of well-bore pressure entering the operating system. Should one of the seals leak, either well-bore or operating fluid will vent out these holes, relieving the pressure. High-strength polymer bearings prevent metal-to-metal contact between all moving parts to minimize seal wear and eliminate galling. Wiper rings minimize external and well-bore contamination of mating surfaces. From a functional standpoint, the D-packer and operating system eliminates the undesirable effect of well-bore pressure over-energizing the packing element. The self-energizing effect, present in some annular preventers, can cause rapid deterioration of the packer during use. To better understand the operation of the DBOP, it is important to gain a basic understanding of the components that make up the complete assembly. We'll first get familiar with the major parts and their correct names. The Cameron D annular preventer consists of only 5 major sub-assemblies, which are easy to maintain and remove when necessary. These are the D-packer, the donut, the quick-release top, the operating system, and the body, with various open, close, and vent ports. Lock ring access ports are also provided. The D-packer is proven over many years of shop testing and extensive field use. Dependable service and long life is assured. This packer is made of special nitrile rubber, which is suitable for H2S service and may be used with oil-based mud. Other compounds are available for low temperature and other extreme service conditions. Shop and field testing has proven this packer to have outstanding wear resistance, which provides long life and reliability. This is largely due to the patented metal inserts, which are molded as an integral part of the packer. These inserts, made of alloy steel, are shaped so that when bonded into the rubber, they will remain in metal-to-metal contact with the adjoining inserts to provide a continuous barrier. In all positions, open, closed on pipe, or closed on open hole, to protect the rubber and minimize extrusion. The unique shape of these inserts causes them to move inward on a spiral pattern as the packer is forced to the closed position, providing a barrier both top and bottom in all positions from open to full closed. Here the packer is in the full open position, with the inserts in solid contact with one another. As you can see, when closing pressure is applied to the piston, a force is exerted through the pusher plate to the donut, horizontally distributing the force around the outside of the packer, moving both the packer and the inserts inward to close around the pipe. Here the inserts have moved along a spiral path toward the center as the packer is closed on the pipe. In an emergency, the packer may be closed on an open hole. Again, the inserts have remained in metal-to-metal contact, containing the rubber against extrusion. The packer receives its closing force from the donut. The donut is a large circular ring of soft synthetic nitrile rubber molded in a solid piece, without any inserts. It seldom needs replacing and outlasts the packer by about 3 to 1. The top surface of the donut is shaped to fit the inside profile of the top piece, and the bottom to fit the pusher plate. When closing pressure is applied, the donut converts the upward piston force through the pusher plate into a horizontal movement of the donut, equally applying force all around the outer diameter of the packer. This force pushes the packer to the center of the preventer bore, sealing the annulus area around the pipe. After removing the closing pressure, the application of opening pressure will release the upward force from the donut, permitting the packer to return to its normally full open position. This is the quick-release top assembly. It remains a sub-assembly when it's unlocked and removed from the body. It consists of the following parts: the top, shown in purple, the actuator ring, shown in yellow, the split lock ring, shown in light green, the 4 actuator screw assemblies, and the top trash seal, which prevents mud and debris from getting into the locking mechanism. The quick-release top provides an easy means for the replacement of the packer. As shown here, it's firmly locked into the body of the BOP by this split lock ring. The locking teeth are formed by concentric grooves, machined into the body and the split lock ring. These locking teeth equally distribute the load exerted against the top by the operating system and well bore pressure. The quick-release top is easily removed by unlocking the split lock ring. This is accomplished by rotating the actuator screws counterclockwise, raising the actuator ring, permitting the lock ring to move inward as it returns to its originally machined diameter. This disengages the locking teeth from the body, permitting easy removal of the quick-release top from the body cavity. This is the operating system. If it becomes necessary, the operating system may be easily removed from the body as a subassembly. It consists of the following parts: the pusher plate, shown in orange, is in direct contact with the donut and is bolted to the operating piston here. The support plate, shown in tan, covers the inner cylinder studs and nuts to provide a solid support for the packer. The inner cylinder, shown in dark green. The outer cylinder, shown in light yellow. The piston, shown in red. The piston, a single cylindrical piece, provides the force that is applied to the pusher plate and donut to close the packer. By applying hydraulic fluid pressure through the close port to the bottom of the piston, upward force is applied to the pusher plate, causing the rubber donut to move horizontally toward the center, applying equal force all around the outer diameter of the packer, forcing it to the closed position. Applying hydraulic fluid pressure through the open port to the top of the piston pushes the piston down, releasing the upward force on the pusher plate and donut, allowing the packer to return to its full open position. As previously stated, the operating system can be removed from the body as an assembly. All metal parts, all the seals and bearings, remain together when it's lifted from the body. An important feature of the D preventer is that it's also possible in the field, with the help of a Cameron serviceman, to remove either the inner or outer cylinder separately. All cylinder and piston seals or bearings may be replaced at this time. Under normal drilling conditions, we recommend 1,500 pounds operating pressure. With the exception of stripping operations, this pressure may be used throughout the life of the packer. Remember that when stripping pipe through a closed annular preventer, the closing pressure should be as low as possible and still maintain a seal that leaks slightly so as to lubricate the pipe as it moves through the packer. For the Cameron D preventer, this approximate closing pressure can be arrived at by using the formula P, which is stripping pressure, equals 0.25 times the well pressure plus 500 psi. An example would be, if your well pressure is 1,500 psi, then P, which represents stripping pressure, equals 0.25 times 1,500 plus 500, which equals 875 psi. The stripping pressure may need to be increased slightly during cold weather operations. Remember that it's important to permit a slight leak to lubricate the packer, to increase packer life. Since all annular preventers are at one time or another used to strip through, we recommend the use of nitrogen pre-charged surge bottles with not less than 3,000 pounds working pressure and with a capacity not less than those shown in the specification section of the D manual. These should be attached, as close as possible, to the open and closed ports. Please refer to the Cameron DBOP manual for recommendations concerning proper hookup procedures for stripping. Up to 3,000 pounds closing pressure may be required in such situations as open hole closures, closing on wire lines or small diameter tubing, and cold weather operations, without risking damage to the preventer or packing element. We recommend that a 3,000 pound BOP operating unit be made available at the rig. In addition, it's wise to observe all proper practices in regards to cold weather uses of hydraulic operating fluids, lubricants, handling and storage of rubber parts, and closing frequencies. Additional programs on the Cameron D annular preventer are available. Part 2 covers the packer changeout procedure for the shop, and a separate program, Part 3, is for field procedures. Part 4 covers the procedures for removal, disassembly, and reassembly of the operating system when it becomes necessary. The Cameron DBOP is designed to permit change-out of the packer in the field, using simple procedures, in the shortest time possible. However simple these procedures may be, it's important to follow them closely. Failure to do so can cause equipment damage or possibly bodily injury. Before you begin a packer change-out, it's very important to be familiar with the written procedures that can be found in the maintenance section of the Cameron D Annular Blowout Preventer Operations and Maintenance Manual. Also available is a laminated card for use in the field, which describes the field procedures for packer change-out. Once you have read either of these, you are ready to begin a packer change-out. First, obtain the tools and new parts which will be required. Clean your work area. And provide the slings and handling equipment necessary to perform the job safely. Slings must be of the proper length and strength to safely handle the quick-release top. The following is a required list of tools and supplies. 2 3/4-inch drive ratchet handles with sockets to fit the actuator screws. Wrenches to fit the hydraulic control line fittings. A grease gun with moly-based grease for lubricating the actuator screws. A good supply of clean rags. An ample supply of 30 to 40 weight oil, or any multi-weight available, and a light multi-purpose grease for lubrication. We recommend that a clean rag be saturated with either oil or grease, and the excess wrung out. This clean, oily rag will be called for as we point out the areas requiring lubrication. Wrenches and sledgehammers to remove the bell nipple and mud return line. A high-pressure water or steam hose to clean the equipment. The minimum of replacement parts needed for the job include the replacement packer and a quick-release top ID lip seal. We recommend that this seal be replaced each time the packer is replaced. With tools and parts on hand, begin the change-out procedure. If you were performing the change-out on the rig site, you would first remove the bell nipple, flow lines, and all other equipment that may interfere with the removal of the top assembly. A program is available showing an actual packer change-out at the rig. Although this demonstration is performed in the shop, the field procedures will be the same, except for the methods used to handle the equipment. Begin the packer change-out by cleaning the exterior of the preventer with a high-pressure water or steam hose. Now apply 1,500 pounds opening pressure to the preventer to assure that the packer is in the full open position. Then bleed off all pressure on both the open and closed lines. We are now ready to disconnect the hydraulic operating lines from the preventer. But first, let's identify all ports and connections. The open ports. The close ports. Dual seal vent ports. Lock ring access ports. At this time, disconnect the hydraulic control lines from the ports on the preventer body, or remove the pipe plug from the bottom open and closed ports. Failure to do so leaves open the possibility of pressure being accidentally applied to the preventer while the top is being removed, creating a potentially hazardous condition. Open the access flaps, located in the 4 positions on the top trash seal. Thoroughly wash around all actuator screws. Inside the threaded lifting eye holes, as well as the inside bore of the preventer. Grease the 4 actuator screws using a grease gun connected to the grease fittings on top of each screw. This action lubricates the actuator screw threads. Also, put some grease on the bearings, located just beneath the actuator screws. Install the correct lifting eyes in the tapped holes in the quick release top. It's important to do this at this time because there may not be enough clearance to install the lifting eyes after the top actuator ring is raised to the unlocked position. With 2 ratchet wrenches, start to unlock the quick release top by operating the actuator screws counterclockwise in pairs of adjacent screws as shown. Turn each screw a few revolutions at a time, or until they start to require additional torque. Then move to the other screws. Continue the procedure. By rotating these screws, we lift one side of the actuator ring then the other. This alternate wrenching is continued until the actuator screws come to a solid stop. And the actuator ring is approximately 2 inches above the body. The quick release top is now fully unlocked. With the actuator ring in its upmost position, remove the plugs from the lock ring access ports and verify that the lock ring has fully retracted from the body grooves. Clean all vent holes as shown here. This can be accomplished by inserting a 1/8 inch wire or welding rod into the vent holes located around the outside of the preventer body. This assures that air can enter behind the top as it is being removed from the body. The quick release top may be removed from the body. Attach the slings to the previously installed lifting eyes. These lifting lines should be long enough to make an included angle not to exceed 30 degrees between the lines. This ensures that the top can be lifted up in a straight and even manner. Never use slings like this, as they're likely to break off the lifting eyes and drop the load. These heavy lifting shackles on the outside of the preventer are designed to lift the entire BOP stack when necessary. Using the correct lifting lines will assure that the quick-release top will not bind while it's being removed from the BOP body. With the top picked up part of the way, look inside the bore to make sure the donut is not coming out with the assembly. If it is, knock it loose, as shown here. When the quick-release top is removed from the preventer body, move it aside. Remove the top ID lip seal. And thoroughly clean the seal groove as shown. Clean the inside and outside with a high-pressure water or steam hose. Wash behind the lock ring. Wipe the inside dry with clean rags. Make certain that the groove is free of mud, rust, and any buildup of foreign material. Inspect the wiper rings to make certain they're not broken and are suitable for further use. This actuator ring seal, located near the top, should be inspected for cuts, tears, or breakage. The quick-release top OD seal, located near the bottom of the assembly, should also be carefully checked. Both these seals are commonly known as wiper rings and are not required to hold pressure. They wipe the mating surfaces clean and prevent intrusion of mud and debris. So long as these rings are in good enough condition to perform this function, it's not necessary to replace them. If the ring is broken, it must be replaced. Set the quick-release top assembly out of the way in a clean place. Clean 2 of the threaded lifting eye holes located 180 degrees apart, here in the top of the packer. Install the lifting eyes. Lift the packer out of the BOP body and set it aside. The donut may stick to the packer. If it does, knock it loose as shown here. Remove and clean the donut. Turn the donut on its side in order to inspect the bottom of the donut as shown here, inspecting it for large cracks. Both the top and bottom inside edges, shown here, will wear away over a period of time. If this wear exceeds an area greater than 1 inch by 45 degrees on both corners, then the donut must be replaced at the earliest possible time. This is easily checked by cutting a 1-inch square from the corner of a piece of cardboard, as shown here. Hold this simple gauge to the inside corners. If both corners are worn beyond this square, the donut must be replaced. Clean out the inside of the BOP body with a high-pressure water or steam hose. It's important to remove all of the mud and debris from the interior, especially around the outer cylinder, here where the top rests. Failure to remove the debris may cause difficulties when locking the quick-release top on reassembly. Install lifting eyes in the support plate and remove. Thoroughly wash underneath. You must also wash around the pusher plate here. These 3 points are prime locations for the collection of debris. The inside should be wiped clean with dry rags after washing. With the body now open and cleaned out, these cap screws, which attach the pusher plate to the operating piston, should be checked for tightness. Using the proper size Allen wrench, check each screw to approximately 50 foot-pounds of torque. After cleaning, check the outer cylinder to see that it's properly seated. This OD shoulder of the outer cylinder should be slightly lower or level with this shoulder of the body, below the locking grooves. If this shoulder on the outer cylinder is higher than the body shoulder, refer to the DBOP maintenance manual, which describes the procedure to be used to fully reseat the outer cylinder. Now let's start the reassembly by reinstalling the support plate. Ensure that each bolt is again located in the recesses in the bottom of the support plate. Prepare a clean rag soaked with oil or a light grease. Use this clean, oily rag to lubricate the locking grooves and the inside of the body. The use of a brush to apply the lubricant is not recommended, since large amounts of grease can cause difficulties when reinstalling the quick-release top. Never use a heavyweight grease or pipe dope. When the body is completely lubricated, reinstall the donut dry. Make certain it's correctly positioned, with the word top looking up. This section clearly shows that the bottom is shaped to fit the pusher plate. Install the new packer dry, making sure it's installed properly with the top side up. The word top is painted on the top side of the packing element. Also, the word top, with an arrow pointing towards the top, is molded into the outside diameter of the packer here. After identifying the top side of the packer, install 2 lifting eyes in the tapped holes, 180 degrees apart. Attach the slings. Lift into place. Install the new packer inside the donut. With a clean, oily rag, lubricate the top and outside of the donut and the packer. We're now ready to prepare and reinstall the quick-release top. Install the slings in the lifting eyes and raise to working height. Wipe the inside seal ring groove clean and dry. Install the top ID lip seal dry, with the lips pointing up. Lubricate all inside and OD surfaces with a clean, oily rag. Spray oil behind the locking ring. Care should be taken to use only minimal amounts of grease. Excessive amounts of grease can cause difficulties in locking the quick-release top in place. Now move the quick-release top into place. Center it over the bore of the preventer body. Lower slowly, ensuring that it is lowered in an even and straight manner. Continue to lower until the quick-release top is fully seated. The actuator ring is now approximately 2 inches above the body. By looking into the lock ring access ports, Check the alignment of the locking ring with the grooves in the body. These teeth must line up as shown before starting to lock the top in place. Rotate the actuator screws clockwise in pairs of adjacent screws as shown. Turn each screw a few revolutions at a time until they require additional torque. Then move to the other screws and continue the procedure until the actuator ring is essentially flush with the top of the body. The quick-release top is fully locked when the actuator screws have become tight, indicated by application of approximately 100 foot-pounds of torque, with no further movement of the actuator screws. The top trash seal must now be essentially flush with the body. Pack the cavity around the head of each actuator screw with clean grease. Then close the access flaps. Use a rubber mallet to ensure a tight closure. At the same time, hammer around the ID and the OD of the trash seal to make certain it's sealed against the top and the body. Now let's check the preventer for proper operation. First, connect the hydraulic clothesline to the close port, or reinstall the pipe plug. Stand a short joint of 3-inch to 7-inch OD pipe in the preventer bore. Apply 1,500 pounds close pressure. When the packer is closed around the pipe and the fluid stops flowing from the open port, watch the open port for 2 to 3 minutes At the same time, check the vent ports. There are 4 vent ports around the outside of the preventer body. And 4 vents in the underside of the body, just above the bottom flange or hub. If there is a continuous flow from any of the ports, there is an internal seal leak. Refer to the D Maintenance Manual troubleshooting section. If there are no leaks, zero the close pressure and again remove the hydraulic line or the pipe plug from the close port. Connect the hydraulic open line to the open port or reinstall the pipe plug. Repeat the test we have just performed by applying open pressure. And again, observe the close and vent ports for leaks. If there are no leaks, zero the open pressure. And reconnect the hydraulic line or reinstall the pipe plug in the closed port. Alternately, apply open and close pressure several times. Observe the packer movement during these tests for proper function. The normal operating pressure is 1500 psi. Operating pressures up to 3000 psi may be used to function a new or a cold packer during winter operations without any damage to the preventer. If the preventer is on the well or a test stump in the shop, a pressure test of the packer may also be performed. Never test your preventer at a pressure greater than the rated API working pressure. Refer to the D manual in the section on pressure testing, or follow the normal rig procedures. To review what we have covered, remember to get all your tools and parts together that will be required before you start. Clean your work area. And make sure that you have the proper slings and handling equipment. Follow the recommended procedures and work safely. You may want to review this program several times to make certain you have the steps clearly in mind so that you can perform the packer changeout safely and in the shortest possible time. Additional programs on the Cameron D Annular Preventer are available covering Introduction and Operation, Packer Changeout in the Field, Procedure for removal, disassembly, and reassembly of the operating system. If you have any unusual problems, refer to the Cameron D Annular Preventer Operations and Maintenance Manual. Or call a qualified Cameron service representative who's already ready to help.